The last one we have here is 5-axis porting. When I've gone through porting examples in the past, I usually focus on roughing, and with working with clients over the last few months, it seems like a lot of people really just want to look at some of the finishing, right? So we're going to go through finishing around, finishing along, and some of the toolpath limits you can use in order to control where you're cutting. All right, so again, all these models are in the help file, so you can download and work with them. And there are tutorials in the help system, so you can go through it as well. This is just a very generic model here, okay? And what we're looking at here is machining a surface like this. Again, there are a couple of different types of geometry sets that you would work with, and some of these are more complex and require additional geometry. One of the things that I wanted to reference is the spline. The software will generate a spline or like a center line down the port, but you can create your own and use this line to control the entry angle as the tool tries to get down inside there, right? So if we look at our example here, we can backplot this, and you can see how the tool is along that spline there in the first example, and in the second example, you can see how it's along a different angle there. Okay, so again, that spline is what you use to kind of drive this. This wireframe is just geometry I sketched to kind of prepare for it. This here is how the model comes. It is a solid model, and today we're going to talk about some finishing routines. All right, as far as the zero position on the job, I'm at the bottom of the model. You kind of need to know the fixture setup for the job so you can see what's going on. I'm going to get into simulation here. This is like a centroid style head table configuration. These are pretty popular in the porting arena. Okay, so and with machine simulation, you have collision checking and different things you can set up. One of the things that's kind of nice is this axis control as well, so you can kind of like see the limits of the machine, and you can also verify the collision checking and the limits that are set up. So okay, so that's really useful. Again, this is under axis control, and then you have the ability to like type in numbers here too. So if you know specific numbers, and again, this is for validation, sanity check, things like that. All right. Let's go ahead and close that out. The other thing I want to talk about in simulation, let's hide this. And we want to view all. What am I doing here? Okay. So, the toolpath itself, components, if you want to hide components, you can just double right click and do hide. So you can hide the table and things like that. You can also change the rendering of the toolpath. And I actually found this to be pretty useful. So in here, you have some different modes for your toolpath, the way that it is rendered. Okay, and as we go down this list here, you can kind of click down through this. You can see the different modes that are available, and axis reversal and things like that. And these are all good indicators or indicators you use for visualizing, using visualization with color to help you understand what's going on with the tool motion, etc. Okay, so definitely something for you to consider. The sequence one is kind of helpful. It's just color coding. But you also have your tool numbers, and again, you can come in here and adjust what the tool number color would be for that routine, so you can see what's going on. All right, I digress. Let's go ahead and just play this through. So we can kind of see the motion. Another thing that's useful with this axis control is it will show you which axes are moved, at what angle they're at. I don't know that these are always absolute values, like because there's the machine definition, but they're usually pretty good indicators as far as what's going on as things change or as you make changes. So again, we can see this is pretty much staying straight on as it goes down this hole. All right. So we want to talk about finishing here. We have this routine. Let's go ahead and look at what's selected here. In this case, I just have this internal surface selected. Again, you can use S on your keyboard and W and T to be able to see what's going on. I've done a cutaway view, or I'll cut the model to make it a little bit easier to view as well. Again, you could use a section view too if you want to see through the model. This is another way that you could do that. And be able to see the cutaway view of what's going on. All right, so that's the surface that we selected. There are surfaces. This one I actually selected my own spline, but the software will generate one automatically for you. This one, it looks like I have one in there too. Let's see here. All right. I didn't really see anything that changed. All right. So to adjust the different modes, again, we're going to just edit this feature. This is going to be a port machining toolpath. When we're in our parameters, this section here is telling you what type of operation you're running, which is really like roughing, finishing along, finishing around, or rest roughing. Okay, so if you're going straight from billet, but you may have a cast part and you're bringing it in. A lot of different scenarios here, but a lot of the requests that I have to do with finishing and seeing the finishing on it. Okay. So we're going to pick our pattern, and actually, let me just kind of start it from scratch. But there are some key settings here, right? So this one's our pattern. Machining surfaces, those are the surfaces that we would want to work with. Again, using your selection manager, you could save that selection and rename it. Right? We can hit cancel on that. This is if you're going to leave stock for finish. This is the automatic spline or spline selection. The area type, this is saying where you're cutting from. Are you going to cut from both directions? Or are you just working from the top? Or are you just working from the bottom? Again, from the top or bottom sometimes is determined based off the geometry. So you kind of look at what side it's on and you can adjust accordingly. Machine 2, you have a bunch of different options here. Midpoint, max from top, max from bottom. So if we go max from top here and we recompute, we'll notice that it's going to go down as far as it can without gouging, right? But the other one that's really nice is that slider bar. So while this calculates, we can kind of take a look at that. But the slider bar will tell you by percentage as far as what you can do there. And from my understanding, you may want to come down, open it up a little bit, come down a little bit further, open it up a little bit more, or leave more stock in the opening section in different proportions. And we're going to show you how to do that here today. But this, we can see kind of the motion that's happening here, and this is max from top, right? If we get back into simulation, excuse me, if we get back into simulation and we play this through, we can see, the angle changes as it gets down further into the part, right? And then you can see the movement that it's making for clearances. I did see some red there. I don't know if I did a check surface on the top of the part, right? So these are that's the machining surface that I picked. If in the simulation I could see some gouging, you may want to make sure you have this selected as a check surface so the tool and the holder isn't isn't colliding with it, right? So let's see where we add the check surfaces. Gouge check surface, select, pick the surface. These are those same clearances, Richard, right? So we'll go ahead and recompute that. All right, let's launch the simulation. So in the first example, it was making collisions because I didn't select that as my check surface. I added as the check surface, and now it's avoiding that holder. Okay. All right. So what if we want to run a different direction? Or a couple of things that we want to adjust. Let's say we want to just cut down a portion of it. So we can come back in here and say user defined, and we can say a percentage of the port. Yeah, so this is by percentage. And then from here, we can do like a negative allowance, for instance, and we'll recompute that. Okay. From there, I'm going to copy with geometry and paste. And just come back into the feature. And then now I'm going to say 14 to 30. And this one we're going to put at 0. All right, so now I'm saying cut a different section by percentage here. You'll see how we did the first section, and then it's going to come back and do this second section here. So a way in which you can stage where it's cutting and the area that it's cutting in. Again, we're going around the port right now. Okay, so we can see this first part here, second part here. There are some options on this entry too. Let me see here. Let's go to here. Surface quality. So these are your tolerances, maximum, minimum, point deviations. Okay, so that's fine control there. This is your step over. If you're selecting a takeaway here, if your toolpath intersects with each other, like while it's trying to go down this down the port, if the toolpath intersects, it won't calculate or it'll stop calculation. So if you have your toolpath set up and it's not going somewhere, you may need to adjust your step over, see if it'll calculate, but it's likely that the toolpath is intersecting with each other and it doesn't allow for that. Okay. What am I looking for? Oh, here we go. The edge rolling. Okay, so if we look at the top, you have some edge rolling, some RAM settings here as far as like how it gets into this. Let's do 50%. Let's finish that and recompute. So in the top one, we can add some edge rolling. Again, using this copy with geometry and iterate, that's a really good way to go so you can see, you can make fine changes and see the adjustment that happens from the fine change. So you can see how this is going to do some edge rolling there before it works its way down. Let's look at what we got on this one here. So we got some toolpath on here. Let's change this one. Let's go along. Okay, similar scenario. We'll go down to 15%. Let's go ahead and compute this. let's blank that one out. Looks a little interesting linking going on there. Again, these toolpaths are optimized specifically for porting. You could accomplish porting in the past with just the regular surface-based strategies, but a lot of the think and workflow and the options have been optimized to make this stuff easier to work with. Let me see here. So that's finishing along. It looks kind of bad. So let's just do, probably my biggest challenge, like in 2D and 3D, I can look at the tool path and a lot of times I can see what's wrong with it, right? Or what's going on with it. And as you get into the 5-axis realm, all of a sudden the tool path motion looks a little bit different. Like sometimes it looks like that's not what it's supposed to be doing, but it is what it's supposed to be doing based on the settings that you've used, based on the inputs that you have and based on that type of tool motion. So, yep, this one we can see working its way down through there. Okay, so let's see here. Finishing around, finishing along. We talked about toolpath limits here, how you can limit it, user defined. We talked about staging in multiple sections so you could have multiple features. Okay, what are the key CAM features takeaways for today's session? It really has to do with copying with geometry to iterate features. So you can change one setting at a time and recompute, be able to reuse that. Okay. Another topic I really didn't get into today is capturing this entire CAM tree. Okay. This CAM tree, you can capture this entire process, the machine, the tools, the stock, the zero, and all the machining features and be able to load it into a new job at the beginning of a new job. So if we create a new file here and we go into our CAM tree, we're starting from scratch here. Okay. If we start from template, okay, then you can come in here and pick a template, and then now that whole job and all of its operations and everything is loaded in there, as far as the tools, the setup location, the stock, okay, and then all the machining features. So this can be pretty useful when you're setting up standardized processes, machining centers, training other people. The biggest for me is trying to make it easier as you're doing work that's more similar. Okay. And, when we're able to make changes to our setups like this, again, this was kind of one of the takeaways. I'm going to change this to number 3. Okay. Yeah. I want to change them all to number 3. That is a very helpful feature within the CAM tree. So, we'll talk more about using CAM tree templates in another training event. If you'd like to learn more about CAM tree templates, make sure to comment. In the question area. If you're using CAM tree templates, let me know. I mean, the other thing that's really important too is the system defaults. Each one of the machining features, you have different settings, right? On the workpiece, off the workpiece, your link style. I don't want to run a direct link. I want to run an arc link always. So set it to arc link and then save it. Save it to that default template. Now every time you load a facing feature, it'll be set to that. So a lot of little nuances there in there. The other thing about the CAD selection, again, we spent some time on this. When you're selecting edges, for a routine, right? If we're going to pick something and you're working off a surface edge, you can right click and choose constant Z and it will select everything that is coplanar to that. You can also right click and choose a loop selection. Again, just don't pick the same edge for that loop selection. So that will help speed up some selections. The other thing here is once you have anything selected at any time, you can come over here and save that selection. You can give it a name. This way you don't have to select it again. So those are some CAM tree templates. Another CAM tree takeaways. Another pretty important feature, this view to normal. Okay, so if you're in a UCS, like I'm in the front one here, I've always had the ability to change my coordinates or my view with the standard what is it? Control 1, Control 2, Control 3. With this option, now it doesn't default on, and as far as I know, you can't default it on, but this views to active UCS, you turn that on, any coordinate system you're in, you hit Control 1, that gives you a top view. It doesn't matter whether the coordinate system is a top view or not. Okay, so this is views normal to your coordinate system. The verbiage on it is a little bit tough. Just think about it. If I'm in a top view, I want to look at it from above. Control 1, you'd be from above, right? Looking down as Z. If I'm on a front view, I want to look at it from the front view. Hit Control 1, I'm looking at it from the front view. Side view, Control 1, side view. And that you turn this on or off by this active UCS. It's very helpful, right? You could add a new UCS, put it on this face here. Okay, we can modify it and align the X direction so that it's going the way that we need it to. Align the Y, align the X and Y. All right, so now this is the coordinate system for that face. Okay, now I want to look down on that, right? We used to use view, normal, and then you got to pick the face, and then you're still dealing with the coordinate system, right? Now, how do you handle this? You're in this UCS. You have views to active UCS. I just hit Control 1. I'm looking down on that UCS just like the normal to that coordinate system. So very helpful there. Okay. Couple other takeaways. If you haven't taken the Launchpad post-processor class, you haven't taken the Launchpad machine building classes, right? I would recommend you do so, especially for 5-axis users. Launchpad.bobcad.com. These are our online training courses. If you come down here to all courses, you have machine definitions 1, machine definitions 2, machine definitions 3. This is going to really help you understand how to better utilize the software by understanding how the machine definition works and the impact that it has on your posting. The other one here, this post-processor basics, this is a great class to have. There's a free preview. I recommend you just use the free preview so you can get an idea of it. This is expensive equipment. If you're a programmer, understanding how the post-processor works, super helpful. I definitely recommend considering this course if you haven't reviewed them. And there are some others in here as well, like maybe not everybody's a 5-axis programmer today. There's a bunch of essential courses here, single courses as little as $75 for a 12-month subscription. Any updates to that course are included with it, where you can get a membership for all the courses as part of a bundle for I think around $500. If you guys have any feedback on the courses, different topics you'd like to see covered, make sure to let us know in the questions or contact us at bobcad.com. Other than that, that's everything I have for today. I really appreciate you all spending some time with me here. Again, thank you so much, and I look forward to seeing you guys in the next training event. See you there.